Hi, welcome to Expanse tension theory. I'm going to present something to you today. It's a document that will be available for you to download yourself. It'll be on the Zenodo archive. There'll be a link in this video so you can access it directly, but I wanted to talk it through. It's called Unexplained Universe Inflections and Accelerations. And that's the heart of why general relativity is struggling at the moment. There are inflections and accelerations happening across the universe in so many different phenomena that we can't explain. And I try and use expanse tension theory to bring a single unifying framework that it can explain, frankly, all of them is the attempt. And what you're going to see is an expanse tension theory coupling modulation chart. And as you know, if you've been through and looked at the papers, expanse tension theory posits that mass resists expansion of the universe as a fundamental expansion energy field from the Big Bang, driving expanse tension ripples that cause the expansion, the driver of expansion since the Big Bang. And there are 5 switching points where matter can couple or uncouple to that expansion field, which I'll explain in the paper. And the objective is to look at phenomena where there are these inflection points to see, do they align with expanse tension theory? Now, the first thing I do is point out where are mysterious inflections and accelerations, like star formation drop-off efficiency, late time cosmic acceleration, the galaxy outer region rotations, and void-driven accelerations like gravitational lensing, where light photons appear to be bending around the void more than the dense galaxy, which is kind of counter to general relativity. But also, an unexplained acceleration is gravity. We have general relativity's curvature of space-time, which is a geometry, but it isn't cause. It's not quantum gravity. We don't actually know why we're accelerating downwards. So I've included gravity in this list. And what I'm trying to do is look at what can expanse tension theory bring to bear. So the framework proposes 5 gates from gate A, B, C, D, and E, and they switch from an uncoupled state of matter to expansion to coupled at the top. Now, if you are uncoupled between expansion and matter at the bottom, you have a normal operating universe. It generally applies to general relativity. If you couple expansion to matter, then you have an acceleration. You have an additional acceleration. And what I'm finding is all dark matter, dark energy, dark phenomena are in regimes which align with these particular plateaus, or the transition to one of those plateaus. Now, what I've also done is defined now precisely where these switches take place as a density, as a kilogram per cubic meter of space. So we've got an absolute density of where these gates switch in the universe. We've defined where they are, and there's a band because it's a continuous curve. So there's an actual gate midpoint, but there is a range of where these gates start and where they finish. Overall, beginning to end, the lowest imaginable density of the deep void of space, all the way up to the center of a black hole. All the way up, so huge, many orders of magnitude from one end of the spectrum to the other. Now, what I've also done in the paper, you can read why the gates happen at those particular points in the universe. So what's happening with the transition of matter through, whether it's plasma, radiation, the matter era. So it explains what's happening at a quantum level that would trigger the coupling switch to happen at that point in time. So please take a look at that, because this is intended to be founded on a quantum field theory basis. Now, some of you remember I had a pattern recognition paper. It came out about a month ago, where I proposed there were 44 cosmic phenomena, and I assessed them against these 4 conditions of state, where I linked, in this case, 11 cosmic phenomena. They all exist in the transition from high to low energy, high to low density, and they all experience an additional acceleration or kick. So this is grid number 1, and all of these phenomena, vastly different phenomena, they all are transitioning from from high to low density, which means they're experiencing this coupling to the acceleration of the universe, and we experience an acceleration like star formation cutoff or galaxy rotation curves. Now, what I've now done is I've now looked and used publicly available information to find out what is the density of where these phenomena exist, and then check the alignment. Does that align with one of the transition gates? And all of them do. They align up. And I link to all of my sources of data that I've used to analyze that. Grid number 2, these are phenomena in a stable low density. So again, you've got a stable but coupled matter mass to expansion. So they are all have an additional acceleration. Now this is like void lensing, gravitational lensing through the void. And again, and also things like the great attractor. Why is the void from the Earth through our galaxy into these other distant galaxies? Why are we accelerating into the void? This can explain it. Again, there is an alignment of these cosmic phenomena where they exist to their densities to a switch density in expanse tension theory, and I have my resources that I've used. I then have grid number 3. Now this is the transition of low to high energy, which is like clumping of matter into solid objects. So they're moving from an anomalous state where you have it in a dark energy state of matter. They're returning to normal relativistic, but the transition is not doesn't follow relativistic principles, because they're moving through this regime change, again matching densities of where they exist to densities of the switch gate. And again, I still have an alignment and resources. Finally, where we live, stable high density environments adhere to general relativity, where we have high dense space, and here we are on Earth conducting Earth experiments. No non-relativistic properties, no dark matter, no dark energy, everything's behaving normally. I have the resources that I've used and sources of data, and I summarize that this has got nothing to do with expanse tension theory whatsoever. This is completely independent, it's completely separate, it's publicly available data that I've gone and sourced, and I've categorized these phenomena against density dependence. Completely unrelated to expanse tension theory as an underlying principle, which, yeah, could be wrong, but this pattern, I think, is sound. Yeah, so I think the pattern of density dependence works. I think it's sound, nothing to do with the theory whatsoever. Now, the paper goes on, and some of you will have seen expanse tension theory predicts a cycling universe of Big Bang to a point where we have a giant void. The small bang is a slow return to a contraction phase, back to a tiny crush and a future Big Bang. And I put that in, it was published in a previous paper, but I'm using it just to remind ourselves of terminology. And then what I do is use the paper against these switches to point out that's the region, that's where we are now experiencing galaxy rotation curves that are dark matter. You know, this is where we exist in planets and stars in a stable, uncoupled state. This is interesting. A whole suite of neutron stars, from very low energy zombie stars in a very low energy state, going up through glitch prone systems that are right on the switching gate, all the way up to very high energy magnetars, dark stars, and massive neutron stars. And because they're existing on that gate, so neutron stars are glitchy, they're odd. And again, they match perfectly to switch gate E. And again, we can explain normal operating universe. And right up here, we have where we have dark matter and accelerations happening. Again, up here, this inflection point, why does star formation drop off suddenly? But because there's a switching point, there's an inflection point that cuts galaxies off at their outer rim. Now this one is where I start at the Big Bang, and I'm coming from high density back down the regime through these gates, And again, and it can explain at the end of this really exponential inflation era. Now, why did we see an inflation era with really phenomenal accelerated universe? Well, because we're coupled matter to expansion, full energy. Why did it stop? That's one of the big mysteries of the universe. Why did the inflation era stop? Well, gate E kicked in, post-inflation era trigger, and we got the reheating event, which slowed down to trigger the radiation era. Then, why did the radiation era stop and switch to the matter era? Well, again, gate D kicked in and pushed us into a state where we have accelerations for dark matter. So that explains that trigger from radiation to matter era. Then we had the galaxy era. We have gate C kicking in, and we have these clustering of galaxies. We now have acceleration. Dark energy kicks in. Why dark energy? Well, dark energy is here on the upslope of B. We have acceleration linked to matter driving the acceleration that we measure. Nothing to do with an invisible, undetectable source of energy. It's about coupling of expansion to mass. And again, it explains why do we see this inflection. Now, just for clarity, I do a reverse time order. So I put the Big Bang here and actually follow this in time. So if you see this, I'm going from high density to low density. I've simply reversed the graph so it's in chronological order. So it's a repeat of the one before. This, kind of funny, I'm speculating. It says it's highly theoretical. If the crush void cycle is true, this then explains how we will return in a contraction of the universe and how that will happen. Now, in a contracting blue shift universe where things are shrinking, the prediction is it would happen very, very quickly. As matter is in a contracting state, it actually drives clumping. Clumping and binding of matter drives greater acceleration until we have runaway black hole mergers and runaway black hole collapse. Some of the analysis I was doing was saying, well, whilst the expanding universe struggles to bind matter because expansion is driving matter apart, in a contracting universe, it could actually contract very, very quickly. And in a fraction of the time of it takes the universe to expand to its ultimate point. But this is exciting because hopefully then the universe isn't going to meet this cold death option that many people see. The conclusion I want to bring your attention to is I've got alignment of a completely independent data that's publicly sourced, nothing to do with the theory. The theory overlay works, could be wrong, I admit it could be wrong, but the publicly available data and the cataloguing and grouping of phenomena is genuine, has nothing to do with theory. But final word says, this pattern is too strong to be by coincidence. And also across the entire range of orders of magnitude, from the smallest things in the universe to the very biggest things in the universe, from the Big Bang up to the point where we are today in late stage acceleration. This is too consistent to be through mathematical error. Okay, it's too consistent. And like we saw with the Hubble tension work, please go and have a look at that. Again, if all 9 probes of the Hubble tension are not only moving in the right direction when I apply ET, they're moving by the right amount in the right direction by ETT. A mathematical error or problem wouldn't create that. So my conclusion is, this can't be by conclusion. I believe the pattern at least is now sound. I link to the papers of the portfolio of Expanse tension theory so you can have a look at them. And of course, I finish with a link to my Expanse tension theory YouTube page. And finally, I say, look, I would love engagement, discussion, exploration, scrutiny, peer review, welcome and invited. I'd like to hear from you. Okay, I'm trying to understand the universe, but please get involved, test it, have a look, share with others who might be interested. And thank you for watching. Much appreciated. Bye-bye.